Gopalan is the Managing Director of Global Automation Private Limited. A graduate of the Madras Institute of Technology, he has held senior positions at Tata Unisys before becoming an entrepreneur. Over the years, he has mentored many professionals and is always a go-to person for many of us when we need a sounding board or just a shoulder to lean on. In all his roles, he has been able to bring in a blend of technology and technical aspects, as well as the business and software aspects of teams and dynamics, and balance them very nicely. Welcome, Gopal. For the benefit of our guests, I thought it would be best if you can introduce yourself.
How do I introduce myself in the context of what we are going to discuss?
Well, I don't know what we are going to discuss. So the context broadly is about the software life cycle.
Right.
But then now we are talking to you as Gopal, right. And I'm sure you have a lot more dimensions than just the software part. So whatever is the way you would like to be known, I thought that's why I said it's probably best if you introduce yourself.
Okay. How would I like to be known? I don't know, but I would like to believe myself to be is I would like to think of myself as a very simple thinking individual and who's generally happy to try out different things in every possible place without risking the very basic thing that I'm trying to do. And I have been in the same industry, software industry, since my electronics engineering, and my love for electronics engineering is still there. And I so try to read up, but because of exposure, I know about software delivery management a lot more than electronics engineering. In software delivery, I've been, like you said, we have been knowing each other for a long time. Right from the time of mainframes and batch programming and those days till now, batch processing till now. So my exposure is relatively long, and along the way, I think I have learned a lot and relearned a lot, and I'm still learning. There's a lot of things that are, many things are the same, yet many things are very different when I observe them today, when I see software development as a process. So it's been exciting, and I want to continue to remain excited by observing and learning more. That's what I believe I am.
Yeah. Thanks, Gopal. And for the benefit of the listeners, Gopal, as it came out even in his own introduction, is quite modest. He has been in the industry for, I guess, close to 4 decades. It may sound a long time, but yeah, that's a time when the industry also has evolved a lot. And from being a programmer to profit center management, including what I like to label as a perennial startup, this whole inquisitiveness and trying to keep reinventing and doing that, Gopal has been very successful in creating things that last. And also amongst our circles, he's also considered as a mentor who is always a shoulder to cry on, or somebody who's a sounding board, who also comes up with genuine, takes a genuine interest in what you're doing and then helps you. So with that introduction, Gopal, since you said that you studied electronics but then got into software, how did you get into software?
Pretty much by accident. I didn't know what I was getting into. It was a campus placement from Tata Burrows. And honestly, all I had done was one course in Fortran. I still remember the question that the interviewers asked about my exposure to computers. I said, I have not seen a computer except one from a distance of about 20 feet on IBM 360 that was there. And I had, at microprocessor level, I can do things, but I really had no hang of what programming was all about, what software was really about. And got into the company, Tata Burrows and learnt everything out there. So whatever I know in software is thanks to my first job. So it was an accident. In fact, after joining in 3 to 4 months, I actually wanted to quit and go back to my soldering, and those were the days. But as destiny would have it, I'm still in software.
Good. And your career has also taken you to different parts of the world. You worked on different technologies, like you said, the mainframe to microcomputers and all that. Is there anything that you can share about the nature of software itself? Does it vary from country to country, culture to culture, or language to language, mainframe to micro, and all that?
There are some differences. I do believe there are a lot of ways in which ultimately, when you look at software, it is the one that which is the part that gets exposed to a user a lot. And when you look at users, their culture, the way they expect things to happen, everything varies. For example, as a programmer, when I got started as a programmer, the key was to try and simplify and codify and do everything around that. So that's how I learned this whole art of application programming. But then very first time I was completely thrown off balance was when I was working with when I was trying to implement something for a customer in New Zealand. And this was to do with wool. And there were colors that he wanted to enter in on particular screen. And we had codified the various colors that he had, and we had asked him to pick from the code. And the names will be long and confusing. I can't even reproduce the names that he had for various colors. But he insisted that he will not enter the code, but he will actually enter the full name. Okay. So it was taking too much space. It was too difficult to key it in precisely. But he will not change. He has been writing those names down in his journal regularly. So he only thought that way. So he just wouldn't change. And as a young programmer, my thing was he's stupid. I mean, why would he want to do something more complicated than, so you had that early programmer arrogance, as I call it, where you think you know more than what the user wants. But then that was the first time I was stopped by somebody and said, you are working for him. He's not working for you. So you need to make sure that you address his requirement rather than trying to force your thoughts onto him. So at best, you should give him an option. So over time, maybe he will convert. So from that point onward, that is when it comes to users. As a culture also, there are differences. For example, I think the Europeans or the Americans or the South Americans, they all have a different aesthetic sense. So the screen that is presented, I felt, had to be designed with that in mind in terms of positioning of, in those days it was, you had these fields in which you could enter. It was not so much of a graphic user interface. Or even now, if you take graphic interfaces, certain color combinations, certain patterns are more appealing to some cultures compared to others. So it's like movies, you find that the movie, same medium, but when same story, same love story itself, when it is presented in different cultures, you actually present it differently. It's like that even when it comes to software. So as a user, they do have a lot of cultural, social background that makes them, like certain ways rather than the other ways. And as a developer, your interest is to make users use your product. So you need to understand that to the best you can, and then take local help to make it more appropriate to that community.
Very interesting. I think particularly when you talk about the arrogance of the fresher, I also remember a similar incident that I went through. Knowing this language, alcohol, I thought I was above everybody else. Others who wrote COBOL. And then when in one of my assignments, I was asked to write a report program. I said, no, why should I write a report program? Yeah. Again, my manager said, no, look, you are here to do a job. Yeah, that's interesting.
And also, we as programmers, we think we know more than the user. That's the problem. We actually have learned it only then. So we know the mechanics that we have been explained, but we don't know the real use as well as the user. And we have a high ego to admit that portion of it. So the computer was more powerful than the application in our mind. That is the problem.
So what was the toughest situation you had to face in your career, technically?
Toughest situation. There have been many. The one that springs to my mind is one of my pet and a project that I loved a lot. This was for an airline called Swiss Air. And we were actually developing an emulator or a simulator, whatever you want to call it, but we called it an emulator that would replace their existing terminal systems. You know, when you go to the airport, you find I'm talking about the 80s and 90s. Now things are a little more different. We used to have dumb terminals and even dumber printers for printing tickets, boarding pass, etc. And these terminals had very strange behavior. And the communication system that the airlines used, which was primarily driven by American Airlines and Sabre, they had a special protocol called the Airlines Protocol, or ALC was the code name for the protocol. Okay. Now, very strangely, that was a 6-bit protocol. And what the airlines did was they tried to, in those days, the communication speeds were limited. So the efficiency of the operator at the check-in counter is to make sure that a passenger that comes is disposed of as quickly as he can be, in terms of checking the person in, printing the boarding pass, giving him the baggage tag, everything to be done in a very quick time. So the emphasis, and it was all experts who would be at the check-in counter. So the lot of codification, it is completely unfriendly when it comes to user interface. It was character interface, and it was actually a bunch of codes that would come, and you interact very fast. And the key to that was to also keep the character set to only capital, so there was no need to have any fancy thing. So the code was a 6-bit code. And as you know, that at a very low level, the communication happens at chip level. When you connect your, let's say nowadays you have Ethernet or whatever it is, you have these bit streams that come and they need to be decoded for you to get the actual information out. So they had this chip that Intel made, which would be the one at the gate where the signal comes in from the network.
Okay.
And most codes were 8-bit codes. ALC was one of those very unusual 6-bit code. So there were in communication, there is something called synchronous communication, in which you had these things called synchronizing bytes. These are bytes that come ahead of every message, so that the system knows that what follows is a message for the computer.
Okay.
So these synchronizing bits were, we assumed it is 2 bytes, which means if your byte size is only 6 bits, 2 bytes is 12 bits.
Right.
So we thought that if you specified it as 2 bytes, it will synchronize with 12 bits. Whereas it was actually 2 bytes as in 8-bit bytes. That is what Intel had done. And they did not though it supported 6-bit protocol, 2 bytes always meant 16 and 8 bits. So the manual should not have said 2 bytes or 1 byte. It should have said 8 bits or 16 bits, but it didn't say. So we went ahead and happily did the whole thing, and there was no problem. The system was working brilliantly when we were testing it from Mumbai, and the host was somewhere in Switzerland. But then when I went to Switzerland at Zurich at the airline, the speed in which the messages came was much faster.
Okay.
So what happened was these 12 bits were coming appended to another set of messages, and so it will not sync. I don't think it's easy for me to explain without a board and a diagram, but basically it will not synchronize. So the whole system wouldn't work. So this was a multi-million-dollar deal, and Burroughs' first break into any airline, any meaningful break into any airline. And we were ahead of everybody else until that particular point. And we thought that it's going to be a deal breaker. So luckily we figured out that the way to handle that is to put 4 padding bits in the front, which we could do, but it would still fail in some cases.
Okay.
So then we had to do an external, Burroughs did an external hardware sync, and then we overcame. But that was a big challenge. It took us a lot of time to do that. So in the same project, there was another interesting, very interesting, again, a very technical problem. We had in those days, you had something called, for error correction, there was something called cyclic redundancy check. Now, these are bytes that are added to messages to make sure that you got the message right. So it is verified at the end. It's like a checksum. And that algorithm was basically, it's a polynomial division that you need to do. And it would take some time for us to compute that at the end of every message.
Okay.
And we were really struggling to bring down the time that algorithm was taking when we were implementing it. And I don't know if you remember, there used to be this game called Rats that people played on these microcomputers in those days, where the rat goes all over and you catch. So there was this guy who was playing Rats. And he was casually overhearing our discussion and breaking our head about how to reduce the number of steps in solving the algorithm. He just, some 15 minutes, he just turned around and said, listen guys, your second step is reducing your input into 1 byte. So why don't you create a table that will have output for each byte and then just look up in the table, then your number of instructions comes down to only 3 per each calculation.
Wow.
That dropped the whole timing dramatically. So these are things that I can never forget. It's just some simple solution by somebody who was not even in the main part of the problem solving. So there are many such situations wherein until you get the solution, you have a lot of anxiety and you don't know how you're going to solve it. And suddenly you feel like you have reached heaven.
That is one takeaway for me, is that I should play more games.
Of course, of course, of course. And have people playing games around you.
Yeah. Good. Actually, that's that triggers another question. See, this whole the airline business, or even the sheep. Actually, I used to think that sheep came only in 2 colors, black and white. Okay, but it looks like wool has so many colors. No, then there have been also changes in terms of how people have been developing software. From the mythical man days, or the IBM 360 that you saw, where we used to have this strictly hierarchical chief programmer team kind of models, to the more agile ways of working, where the emphasis is on teamwork, how teams kind of get together, how teams kind of solve the problems together and all that. So in your career, you would have seen a lot of these changes or shifts, or even the fads that were there. What is your take on the current agile approaches that people are looking at?
My take actually is simple. I think that there's a lot of hype around it. I do agree that Agile as a framework is forcing people to be more nimble and alert and do quick deliveries. Do delivery quickly so you fail quickly, so you get time to correct quickly. All that, I think there are positives that have come in this framework. But I think all through, my belief is that as a part of a delivery team, one of the key things is to always be focused on what is to be delivered at the end. Let me rephrase myself. For example, you need to really look at a situation and see what that situation demands, and then react according to that. For example, let us say in those days, nowadays hardware is like highly standardized. We have completely limited number of platforms. So the challenges of having to wait for a particular hardware and a particular platform, all that has gone. But in those days also, when it was like that and suddenly you don't have a hardware, how do you react to say, how do I utilize the time between now until like the time I get the hardware? So you thought on your foot and you said, okay, I will do this. Let's say I will probably develop pseudocode and try to do some walkthrough. So the key I feel is that as a project manager, or as a person who is whatever title you give, as a person who is responsible for ultimate delivery of the software, I need to look at the situation and see what is the best way to utilize the resources continuously without wastage, and you know, make sure that you utilize that in a way that is focused towards delivery of your ultimate software is the key to anything. So I do believe there are some inherent strengths to different development methodologies. Like Agile has certain strengths, and I believe Waterfall did have certain strengths. Everyone have their own strengths, but you should not just rely on the strengths. You should actually add your own value by trying to see what the variations in situation is and try to adapt according to that, and take your team along with that. That's the whole thing. And I think it is still a heavily people process, because even if you take in the current methodologies, if you are not able to be sensitive to every team member and address the difficulties that are faced by the team member, and then help that difficulty to be overcome in order to help go on as per your plans and estimates, that's the key. So I do believe there are inherent strengths in each methodologies, but I don't think that itself is an answer to on time, on budget delivery. I don't believe in that.
Okay. We spoke about this before this discussion. So just like you talk about the process model or the methodology, what is your take on the technology itself? While some people call it is all completely revolutionary, changing, to some extent, it seems to be kind of going back, starting with mainframes which are monolithic, then all these distributed systems, and now again cloud is trying to consolidate it. And earlier we used to have this thing of the loop of learning from whatever is happening, which is now probably getting embedded in the AI, machine learning, deep learning, and all that. So people also talk about the programmers being extinct, etc. So what is your take on the technologies as applied to the software development process itself?
Yeah, I think there has been a lot of evolution. I completely agree with that. But even today, I think I would call them developers rather than programmers are relevant. The challenges and where the effort goes have been shifting continually. For example, if you remember when we started, you couldn't even take communication for granted. You needed to write NDL code for making sure that the communications are all right. You needed to worry about limitations in terminal devices, and there were a lot of things that had to be taken care of. So a lot of focus was going into doing what today is considered as very low level things, and today what is assumed and completely taken for granted could not be, and you had to work at very low levels. So there has been an evolution in the way development itself happens. Lot more can be achieved in terms of if you take some measure, let's say story points or whatever it is, you can do a lot more today than you had to, because the infrastructure has definitely changed. And I don't see this point. Lot of times hype is about specific things like deep learning or this or that. But I think the real revolution that is making a difference is the integrated fabric in which we are delivering solutions now. So if you take various developments, communication development, speeds of communications have gone up. Standards in communications have evolved heavily. Application interfaces have evolved heavily. A lot of uniformity has come in the way applications talk to each other. Things that were a challenge and we had to have external negotiators, they have all come down. So yes, it is becoming simpler. For example, you could put together a website, a commercial website, which allows for even buying, selling, and a whole lot of things with open software without writing a single line of code. So that is where we are now. So the emphasis for the developers will be in translating the requirements in a quick and meaningful way onto the existing platform. So the platform that is offered definitely has gone through a revolution from the time we started till now. There are a lot of patterns that are common. Like you said, things have been moving back and forth. Host based, then it is like, everything is distributed. Then you have this client server, those kind of things have been, there are a lot of patterns that have kept repeating. But the integrated platform that is available now is far superior to what we had. For example, we didn't think something like cloud would have been meaningful without the kind of general communication infrastructure that has become prevalent across the world. Cloud in idea could have been there. Host systems have been there. Putting something somewhere else and doing the processing there was always there. But the meaningfulness of such technologies is a lot more because other technologies have also developed. So when I look at it as an integrated thing, there has been a tremendous change and ease with which we can do. I don't know if I answered your question very well, but those are my muddled thoughts about it.
Just your views. So just that one bit which I'm still curious about is if you kind of project the acceleration or the change in technologies. One thing that you mentioned from the the NDL days to cloud, making the interoperability or creating maybe more complex global systems easier from an infrastructure point of view. If you extrapolate that, so that is the question, saying that the need for a developer or a programmer in terms of the skill sets is also probably changing or has changed already. So what would be your guidance or tip for those who are aspiring to get into software today or tomorrow?
Having a tools that are available to, having a knowledge of the tools that are available to. I think I missed you. I think I talked while you were talking. Can you repeat the whole thing, Shiv?
Yeah. Yeah, in between, I guess we also had some internet issues. Yeah. See, you spoke about the change in the technology and the infrastructure, from being more discrete pieces that we had, whether it is the NDL kind of environments, to with the cloud and standardization, the ability to create, say, complex applications or globally available applications has become simpler. You are also talking about no code kind of environments. Now, if you extrapolate that, what would be your tip or guidance to people who want to get into software now?
Would be to spend more effort in understanding how the human mind seeks answers and how it tries to solve problems and where it does not want to keep repeating the same work. If we are able to pay attention to that and then take those requirements and translate it with the knowledge of the kind of tools that are available, that is where. So you need to be very knowledgeable about the variety of tools that are available at your disposal. For example, if somebody comes to a developer and says, I want to put together a website and I want to have people calling in on their phone and getting answers to their questions. At the same time, also want to search and then get certain pictures delivered to them in their handheld mobile. There could be variety of requirements that will become, which are very new, which would not have been things that we would have thought about 10 years from now. Now today, that same thing can be easily done with tools that are available from Google, Amazon, or Microsoft in terms of voice interfaces. In fact, Amazon is, I think, already, if not announced, it's going to announce something where you can use their voice as an interface that you can actually program and get it to answer your questions, and you can write specific voice-based apps. So it's going to become more and more like, and there are a lot of AI tools available also, learning tools available. So you should be able to understand. So don't focus on learning a particular language. Rather, try to learn the platforms that are available, tools that are available that can be translated to something that the user can actually explore towards solving his own problems. For example, if you remember when we started this company in '94, COM objects were becoming very popular, and Microsoft came up with this whole COM architecture. The whole idea with which we started this company was to build a repository of application components that can be sutured together to build any kind of application that anybody wanted. It was a very ambitious plan, but it was something that was not unthinkable. It could have been done. But the thing is, lot of assumptions that you make keep shifting and you lose focus and you don't get there. But the industry gets there. So today you can actually, if you take some of the things that are available in open source, let's say, even if you take a specific platform like WordPress, the amount of tools that are available, you can create a meaningful website which can actually do some transactions with just the plugins that are available, and you can do that. Like that, imagine you are going to be you will be made available a lot of platforms, a good technical understanding of what these platforms offer, how they can be sutured together to deliver a particular solution. That is where I would recommend developers focus. That is one level of developers. The other ones are the ones that create the tools. There you need to actually have sharper, understanding of maths and theory of automata and whole lot of fundamental sciences. That is one area you could focus and develop. So these are two things. If you're an application programmer, focus on tools, how to bring them together, and understand communication so that you can talk to the users, understand their requirements, and translate them into solutions.
Very nicely put. Yeah, actually, it just triggered one thought. When we started this conversation, you spoke about the need to understand what the user wants, whether it is the wool color or whatever. And I think that theme still continues in your advice to the people who are entering now, is about solving problems, having that empathy for users. So I think that's a great message, Gopal.
Thank you.
Yeah. So thanks a lot for taking the time to share at least some snippets from the nearly 4-decade-long career. I'm sure our audience might have more questions, and we may probably have to do maybe a couple of more episodes on the stories. You have a very nice way of bringing in the technology, the challenge, and the solution in the form of a nice story. Yeah, thanks a lot, Gopal.
Thank you, Shiv, and it was a pleasure. And many of the things that I've said, I've learned working with you. So that also I want to share at this point. Thanks a lot.
Thank you, Gopal.
Bye.